we're going to assemble an album. In this case, so just make it an EP, a 3-track affair, because otherwise it'll get too long and tedious. And we're going to assemble that, and then we're going to create a Q and WAV file. Then we're going to convert those through ddptools to a DDP fileset, which is something that's required by a number of CD manufacturers. So let's start then. This is SAWStudio, which is my DAW of choice. Your mileage may vary, and there's a particular plugin here which allows you to generate cue sheets, which I find very useful. So the first thing we do is get the thing so we can see the output track and the input track together. There is only one input track because we're just lining things up on the timeline, and we have to make sure that the actual multitrack is working at 44.1K, which is what's required for CD. If you don't do that, then the cue sheet generator will object. However, you can drop things that aren't in 44.1K into the timeline, and SAW will do the conversion with as good a quality as it can. So let's just have a look for a folder of files. Let's just open that folder. We've got 3 tracks, so I'm going to start off with that and add that to the multi-track hot track, which is there. Then I'll try this slightly more contemplative piece and add that to the multi-track hot track, and finally we'll finish with that one there. Now we've got the 3 tracks on the timeline. You'll notice that the first track got a little bit of breathing space at the beginning there, but it's not a 2-second start delay that you need for some authoring systems. So this is what you expect the punter to hear. This particular first track dies off, and there's naturally a bit of space there. So I'm going to leave that. That sounds pretty good for the space between that and the next track. Then here, one ends abruptly and the other one starts abruptly, and why not? Let's go for it. So we've got this not very exciting end by this chap, and immediately cut into the final piece. But there's no reason why you shouldn't move these things about in the timeline to create bigger gaps. This is really all about making the album sound right from a timing point of view. Now we go to the output track and we have to look at the final resolution effects area, and we're going to add the cue sheet generator, which is by John Marshall Smith. It's a very useful plugin. Now this allows us to define track points, and the deal here is that you may have produced a fantastic WAV file which you want to put onto your CD, and you may want these files to run really closely contiguously. If you're doing a straightforward pop album, you might want a 2 seconds gap in between each track, but you might, especially if it's a classical piece of music, you might want segues to be seamless. And you've produced your WAV files at some arbitrary length and you think that's fine, but CDs work on the basis of 75 frames of data per second, and if you butt 2 things up and then you assign a start point, but if the start point doesn't fit at a particular frame boundary, you will get glitching if you are jumping from track to track. You really don't want that. So you can line the things up here with arbitrary breakpoints here, but say I want to put, let's have a look at this second track. That's a long time. That's probably reasonable. A little bit of breathing space, so if somebody presses the track select button, they get a chance to appreciate the track as it starts. So let's say we wanted a track start point for the second track here. I can add that, but you will notice that you probably didn't notice. Let's delete that and try again. If I want it to be here and I add a track point, notice that the cursor line has moved slightly, and that's because this cue sheet generator is dropping that track at the next 75th of a second boundary. And that's quite important, because if we now move on, say, to the third track where the thing's changing abruptly, you think, well, it'd be nice to have the track start directly at that boundary. But in fact, if I drop in a start point, it's going to start after the track has started, which is not quite what we want. So again, we're going to kill that, and we're just going to say, well, maybe it's here somewhere. That's reasonable, isn't it? So we drop in a start point there, and now it's moved it slightly, but not enough to upset what we're doing. And finally, we nominate the end of the piece. Now again, I can add a track point there, which is actually after the end of the waveform. Now this DAW doesn't really like rendering stuff where there's no audio there at the end of a piece. So what we're going to do is just to kill that one, and we'll move back to some arbitrary place like here. It's quiet by that time. Let's have a look what's going on. Yeah, it's down to dither by then. So we'll just add that, and now we have the final position. So let's bring the waveform down. So now we've got start, which is that yellow point, finish that yellow point, and then these are track points in between. And you can see now in this list we've got room to define the tracks. Now it so happens that I have ISRCs for these. So the first one is okay, this guy. And so all of these are collected. Let's do the tracks. So that's that, and that's that, and go back to this. Now we've got ISRC, which of that is that. Okay, and that one, and that is. And again, that has got that one, that, Right, we have now defined the tracks, and that's the information that will go in the CD text. Let's have a look at the disk now, the disk setup. We're going to go for one Q file and one large wave file. So a large wave file is basically the entire waveform you see there for the whole CD, and the Q file is a text file that tells the authoring software where the start points are within that file, or multiple files if you've got multiple files. But we're going to do it as a single file. I'm going to put them in a folder called QWave source, and I'll say why that is in a minute. So I'm going to call that retrospection EP, and that's going to be a Q file. And it will create a WAV file with the same name, different extension. Media catalog number is your UPC code, which is a 13-digit code. So I assume that no real product has got a code like that. Here's the name of the actual CD, or EP in this case, and we know that it is this guy. Time to have permission to use his stuff. So there we are, we've now set it all up. So what we now need to do is, we've got all the WAV files there, so now we're going to process that down to create the Q and WAV files in accordance with what we set up here, and we process those down to the FX modules. It is 44.1 kHz by definition. 16 bits, doesn't matter whether your project was 24-bit or 16, it'll bring it down to 16, and you can dither if you want. This reminds you of what you're doing, and we're okay with that. So this will now work its way through and create that composite. Now we don't want to do anything else with that at the moment. So that's enough of that. We can now we can save this as something. That actually saves the Q sheet information, so doing that again is dead easy. So let's look at what we've got now in that QWave source. We've got these two files, the Q file and a WAV file. If we look at the Q file, we can look at that with Notepad, and we can see that it's got the catalogue number, it's got the title of the EP or the production, performer and songwriter, the one WAV file. If there's more than one file, if you decided to have this as several WAV files, there would be several WAV files referenced. Each track now, it tells you it's an audio track. Why should it be anything else? But anyway, it could be data I suppose, but it's audio. And each track's got its ISRC, its title, its performer, songwriter. Now interestingly enough, the title, performer, songwriter you probably get on CD text it's very difficult to extract ISRCs from CDs. You need special software for it, and it's a real pain in the neck. Anyway, that track starts at the index, which is 0 minutes, 0 seconds, 0 frames, obviously at the beginning. And then the next one starts at 44 seconds, 59 frames, and then 3 minutes, 53:11. It's worth looking at this WAV file while we're at it. So you can see that you've got the first track to here, then the second track to about here somewhere, and the third track there, but it's all one WAV file. But let's just blow up the front end of this and see what we've got. We've actually got a period of something like 0.725 a second. We've designed that in. So this WAV file represents exactly the right thing. Now, CDs tend to require a 2-second gap before the start of the first track. That isn't in here. Otherwise, that dead zone there would be 2.75 seconds long, not just 0.75. So the authoring software will normally do that. We just need to be aware of that. Right, so I've just sparked up a command prompt. We're going to look at the DDP tools that are free, downloadable from the internet, quite useful, and a command line tools that will allow you to create the DDP file set, which disk manufacturers often request. That file set is something that kind of munges the existing Q and WAV file information into slightly different format for their purposes. Bit of a nuisance, but hey, we've got to go through it. So these tools are very useful. If I show you what we've got, not very much. The key one is Q to DDP, which turns a Q and WAV file into a DDP file set. Then, having done that, we can have a look at the DDP file set we've produced by DDP info. There's also something to do with CD text, but you don't need that. And the information for these is in these text files. We'll tell you all about the switches, so it's up to you. But here's a basic thing. We're going to start off with the Q to DDP command, and we're going to ask it to produce a file set which includes a Q file, which includes a binary text file. We're going to give it an identification, a master name, and this is about the only time you get an opportunity apparently to identify this DDP file set, and it could be anything you want to call it to identify this file set uniquely. So let's call it retrospection pp underscore I don't know, say ver01 or something like that. It's not printed anywhere, but you can see it in the file set. So there we are. And now we've got to we're going to tell it what QWAV file to work from, and in this case we've got a folder, it's in M drive, and I called it QWAV source. That's the folder, and we're going to point it to the Q file. So retrospection ep.q, and then we're going to tell it what folder to put the DDP file set in. So I've already created a folder called DDP1 under the M drive, and let's see if that will work. Hooray! So it's already identified the various tracks on it, and it's rewritten that WAV file as a .dat file. It is a WAV file, but it doesn't have the WAV file headers, so it's just like left, right, sample data. So it's raw audio data, and then various other files, including CD text information. Now, what this does do is to calculate the checksums in MD5 and CRC32 form, publishes those in the file set, which your disk manufacturer can subsequently use to check that that he or she have actually got the right files and that they're not being corrupted in all the WeTransferring or Dropboxing or whatever you've done, or sticking them on a memory stick. So just check against any kind of corruption there, because clearly if there's anything wrong, that can screw up the project and you don't want that. We can actually verify that by using the DDP info thing. So let's do -y and then let's point it to the folder and see what it comes up with. Nothing. That's it. It helps if I send it to the right folder. It tells me it's okay, and it's just checked the MD5 and CRC32 checksums and everything's hunky-dory. So that's useful. And that's what you would get as a cue sheet. Now it's interesting here because the cue sheet now is pointing you to a binary text file, and it's also pointing you to the .dat file, which is again that raw audio file which it tells you is binary. One of the other things we can do, if you really want to close the loop on this and make sure it's all correct, is that you can get this DDP info to create a cue and wave set. So you've gone in with a cue and wave set, it's created its own internal files in the DDP file set. Now you can export that as a cue and wave file pair, and you can compare those with what you put in the first place. So let's try that. Now that's -w, and then we're going to give it the name of a file. So let's say I've already created a folder called extracted cue wave, and then I'm going to call this extracted.wave. You have to put that extension on the back end of it, but then obviously you need the folder, which is M, to get the information from. And let's try that. And it's done exactly what it says on the tin. So it's gone to DDP1 folder with the DDP file set. It's created a cue and wave set in extracted cue wave. So if we now look at that, we'll see what we've got. I'm doing this on Audacity because Audacity is very good at opening all manner of files. So let's just look at what we put in to start with. That's our cue and wave source. So let's look at the original wave file. That's that. Now we're also going to import some raw data, which is what's in the DDP file, because we know that doesn't have headers, and we know it's standard CD audio, so it's signed 16-bit PCMs, 2 channels, little endian 44.1. We know that's correct. And we're also going to import, let's just reduce the size of these a little bit so that we can get 3 in here. There we go. And we're now going to import audio. Now we're now going to import the extracted cue wave file, or rather the extracted wave file. And there we are. So what's interesting now is to look at the beginning of these files. Let's get right to the beginning. And you can immediately see the difference there. Just get zoomed in a bit. There we are. So this was the source file, and that's got effectively just that that 0.75 of a second, whatever. And here's what's in that raw data file. That's 0.75 plus 2 seconds worth. And here's what's been spat out by the system. That is just the original value. So there we are. We've now got out what we put in. Let's just reduce the size of that track so the waveforms look the same. The waveforms here are absolutely identical. It's just copied the data over. So don't get worried about that.